Topic: Quadratic graphs. Learning area: Graphs.
We are familiar with quadratic equations and different methods of finding the solution for it. Quadratic equations are in the form of ax squared plus bx plus c is equal to 0, where a, b, c are real numbers and a is not equal to 0. Any equation of the form p of x is equal to 0, where p of x is a polynomial of degree 2, is called a quadratic equation, and its standard form is given as shown. A few examples of the quadratic equation are given here. Quadratic equations can be solved by different methods. They are factorization method, completing square method, formula method. We can graph the quadratic equations also. Let us learn about graphic quadratic equations in this lesson. At the end of this lesson, the students will be able to recall about graphs, know about quadratic graphs and how to plot them, know how to solve the quadratic equation graphically, know about special graphs. Graphs are diagrams that show information about two different quantities that are related to each other, like weight is related to height. In general, graph is defined as let function a to b is given where a and b are subsets of R. The set of elements of the ordered pair x, y belongs to A, where y is equal to f of x of all such ordered pairs x, y is called the graph of f. A polynomial function in x can be represented by a graph. The graph of a first-degree polynomial y is equal to f of x is equal to ax plus b, where a is not equal to 0 is an oblique line with slope a. The graph of a second-degree polynomial y is equal to f of x is equal to ax squared plus bx plus c, where a is not equal to 0 is a continuous non-linear curve known as parabola. Here are few examples given for graphs. We know that the quadratic functions are in the form of y is equal to f of x is equal to ax squared plus bx plus c, where a, b and c are real constants and a is not equal to 0. Consider the function y is equal to ax squared plus bx plus c. By completing squares, the above polynomial can be rewritten as shown. From the above expression, we can write the vertex of the curve as v is equal to minus b by 2a, 4ac minus b squared by 4a. If a is greater than 0, then the curve is open upwards. It lies above or on the line y is equal to 4ac minus b squared by 4a, and it is symmetric about x is equal to minus b by 2a. If a is lesser than 0, then the curve is open downward. It lies below or on the line y is equal to 4ac minus b squared by 4a, and it is symmetric about x is equal to minus b by 2a. Here is a table with set of quadratic polynomials and the nature of their graphs with vertices. Let us learn the procedure how to draw the quadratic graph, which is in the form of y is equal to ax squared plus bx plus c. Construct a table with the values of x and y using y is equal to ax squared plus bx plus c. Choose a suitable scale. The scale used on the x-axis does not have to be the same as the scale on the y-axis. It can vary. Plot the points on the graph paper and join these points by a smooth curve as the graph of y is equal to ax squared plus bx plus c does not contain any line segments. Now the graph is drawn. Example 1. Draw the graph of y is equal to 2x squared. Solution. Let us assign the integer values from -3 to 3 for x and form the table. Take the graph paper and plot the points which are obtained in the table. Now join these points by a smooth curve. Thus, the curve obtained in the graph paper is y is equal to 2x squared. It is symmetrical about y-axis. That is, the part of the graph to the left side of y-axis is the mirror image of the part to the right side of y-axis. The graph does not lie below the x-axis as the values of y are non-negative. Let us learn how to solve the quadratic equation ax squared plus bx plus c is equal to 0 graphically. Let us graph the given quadratic equation first. Find the point of intersection of the curve with the x-axis. The x-coordinates of the points of intersection of the curve with the x-axis will give the roots of the given equation. Example 4. Solve the equation x squared minus 2x minus 3 is equal to 0 graphically. Solution. Let us assign the integer values from -3 to 4 for x and form the table. Take the graph paper and plot the points which are obtained in the table. Now join these points by a smooth curve. The curve intersects the x-axis at the points -1, 0 and 3, 0. Here, the x-coordinates of the above points are -1, 3. Hence, the solution set is -1, 3. On the x-axis, y is equal to 0 always. The values of y are both positive and negative. Thus, the curve lies below and above the x-axis. The curve is symmetric about the line x is equal to 1. Example 5. Draw the graph of y is equal to 2x squared and hence solve 2x squared plus x minus 6 is equal to 0. Solution. Let us assign the integer values from -3 to 3 for x and form the table and graph y is equal to 2x squared. Take the graph paper and plot the points which are obtained in the table. Now join these points by a smooth curve. In order to find the roots, let us solve the two equations. Let us write the two equations as 1 and 2. On replacing 1 in 2, we get y is equal to minus x plus 6. Let us graph the equation y is equal to minus x plus 6 by constructing the table. Here the curve and the line intersect. The point of intersection of the line and the curve is -2, 8 and 1.5 and 4.5. The x-coordinates of the points are -2 and 1.5. Hence, the solution set is -2, 1.5. Let us learn about some special graphs, namely direct variation and indirect variation. If y is directly proportional to x, then we have y is equal to kx for some positive k. In this case, the variables are said to be in direct variation and the graph of this is a straight line. If y is inversely proportional to x, then we have y is equal to k by x for some positive k. In this case, the variables are said to be in indirect variation and the graph is a smooth curve which is in the form of rectangular hyperbola. Let us work out a few problems on the special graphs. Example 8. A cyclist travels from place A to B along the same route at a uniform speed on different days. The following table gives the speed of his travel and the corresponding time he took to cover the distance. Draw the speed-time graph. Solution. By looking at the table, we can observe that as x increases, y decreases. This type of variation is called indirect variation. Take the graph paper and plot the points which are given in the table. Now join these points by a smooth curve. The graph which we obtained is the graph of indirect variation. Example 9. A bank gives 10% simple interest on deposits for senior citizens. Using the given table, draw the graph for the relation between the sum deposited and the interest earned. Solution. By looking at the table, we can observe that as x increases, y increases. This type of variation is called direct variation. Take the graph paper and plot the points which are given in the table. Now join these points by a smooth curve. The graph which we obtained is the graph of direct variation.